name is Matthew Joshua Udukomose. I am a mathematics teacher in Nigeria Tulip International College. I will be solving some of the JAMB Past questions with you today. So the first question says, if 55 base s plus 52 base s is equal to 77 base 10, find what s is. What is the base? So since this number is in base 10, we don't know what s is, so we're trying to express all these other numbers in base 10 this way. So it's going to be 5 base x plus 52 base x equal to 77 base 10. So we can assign superscript 0, 1, 0, 1, so that we can express them as powers of the base. So this is going to be 5 times x raised to power 1 plus 5 times x raised to power 0 plus 5 times x raised to power 1 plus 2 times x raised to power 0 equal to 77 base 10. So this is going to be 5x plus 5 times 1 because x raised to power 0 is 1 plus 5x plus 2 times 1 equal to 77. So if you clear this, we are going to have 5 plus 5x plus 2 equal to 77. So we collect the like terms. 5x plus 5x is 10x plus 5 plus 2, that's 7, equal to 77. So we can collect the like terms, possibly subtract 7 from both sides, minus 7, minus 7. So this is going to be 10x, here is 0, and equal to 17. So we divide both sides by 10 to have 10x divided by 10 equal to 70 divided by 10. So this is going to be equal to 7. So the result for this is 7. So the answer is C. Next question. This is just like the first one. 6R7 base 8 is equal to 511 base 9. None of them is in base 10. So what we do, try to convert all of them to base 10 by assigning superscript. This is 0, 1, 2. This is 0, 1, 2. So we can expand now. This is going to be 6 times 8 raised to power 2 plus r times 8 raised to power 1 plus 7 times 8 raised to power 0 equal to 5 times 9 raised to power 2 plus 1 times 9 raised to power 1 plus 1 times 9 raised to power 0. So this is going to be 8 or 6 times 64 because 8 squared is 64 plus r times 8 plus 7 times 1 equal to 5 times 81 plus 1 times 9 plus 1 times 1. Anything raised to the power of 0 is 1. So this is going to be 6 times 64. So this will give us 6 times 4, that's 24. 6 times 6, this will give you 384 plus 8r plus 7 equal to, this is going to be 405 plus 9 plus 1. So we clear up everything by writing 8r plus 384. That's 7 plus 384. 384 and 7, they are like terms. So it's going to give us 391 equal to, this is going to give us 409 plus 1 is 10 plus this is going to be 415. Then this is going to be 8r equal to 415 minus 391. So this is going to be 8r equal to 5 minus 1 is 4 And 11 minus 9 is going to be 2. 3 minus 3 is 0. So this 8 arrow is equal to 24. If we divide both sides by 8, it's going to be 8 arrow divided by 8. 24 divided by 8. And arrow is going to be equal to 3. So you can see this answer becomes C. So the next question is going to be in this form. Now, I still have something like 2q 3 base 5 is equal to 7 till 7 base 8. None of them is a base 10. So we try to convert all of them back to base 10 by assigning first what is called superscript 0, 1, so that we can now expand in powers of the base. So first, this is going to be 2 times 5 raised to power 2 plus q times 5 raised to power 1 plus 3 times 5 raised to power 0. Then equal to 7 times 8 raised to power 1 plus 7 times 8 raised to power 0. So this becomes 2 times 25, because 5 times 5 is 25, plus this is just going to be 5 cubed. 5 raised to power 1 is 5 times q, 5 cubed, plus 5 raised to power 0 is 1. So 3 times 1 is going to be 3, equal to, this is 7 times 8, plus the same way, 8 raised to power 0 is 1, and 7 times 1 is 7. So 2 times 25 is 50, plus 5q plus 3 equal to 7 times 8. I think is 56 plus 7, right? So if you add this, it's going to give you 63. And this is going to give you 5q plus 50 plus 3, that's 53. So if you collect the like terms, 53 will go to the right. So this is going to be 63 minus 53. And this is going to give you 10. So 5q is equal to 10. So we can go ahead and divide both sides by 5. And that's 1. 1 times q, q. So the answer becomes 2. So the answer is A. So this is it. So we are going to the next question now. Next question is this. Now, find the value of this in the base 8 from the table below. If you check the table below, it shows the conversion. So base 10, 1, 2, 3, 4, 5, 7, 8. Now, base 8 equivalent, 1, 2, 3, 4, 5, 6, 7. There is no 8 in base 8. 8 is 10 in base 8, because it's going to be 8 divided by 8, 1 remainder 0, so it becomes 10. Also, 1 is 1 in binary in base 2, 2 represents 10, 0, 1, 1 is 3 in binary, like that. So this table, we are going to simply use it to what? Do the conversion. Now, what we will do first here is to write out this number you can see here. We'll write it out and group it in threes from the right. So I'm going to have something like 1, 1, 0, then 0, 0, 1, then I'll have 1, 0, 1. So it's grouped in threes. So that this is the simplest way to quickly look at this question. If you check from the table, 101, 101 here represents 3 in base 8, because we are looking at this number in base 8. So this is going to be equal to 3. Why this represents This is 100. 100 represents 4. So this is going to be 4. Now you have 101. This is 101. 101 represents 5. So this is 5. So we can therefore say that this figure 101, 1001, 011 in base 2 is equivalent to 543 in base 8, and that forms the answer. So our correct answer here, 543 is going to be A. So that's it. Now, next question. Next question is this. X is already in base 10, but 23 is in base 5. So what is X? So what we do, we convert this 23 to base 10 also, so that we'll have something like this. I'm going to assign my superscript 0, 1, so that I will have 2 times 5 raised to the power 1 plus 3 times 5 raised to the power 0 equal to 2 times 5 plus 3 times 1 equal to 10 plus 3. And this will give me 13. So 6x is in base 10. This is also in base 10. So my answer is going to be D. So next question. Next question is this. Find x and y respectively in the subtraction below carried out in base 5. This subtraction is carried out in base 5. So what we are going to do is this. We are going to arrange this problem this way. 4, 2, 4, 3 in base 5 minus 1, 3x 4 in base 5 is equal to y 3 x 4 in base 5. So we'll look at what we can do to convert all these ones to base 10. So let's start with this by assigning superscript 0, 1, 2, 3, 0, 1, 2, 3, 0, 1, 2, 3. So we can go ahead and convert all of them to base 10. First, this is going to be 4 times 5 raised to the power 3 plus 2 times 5 raised to the power 2 plus 4 times 5 raised to the power 1 plus 3 times 5 raised to the power 0. This is going to be 4 times 1, 2, 5 plus 2 times 25 plus 4 times 5 plus 3 times 1. So this is going to be 500 plus 50 plus 20 plus 3. And at the end of the day, we have 573. 573 in base 10. So this is the first number. The second number, we have 1 times 5 raised to the power 3 plus 3 times 5 raised to the power 2 plus x times 5 raised to the power 1 plus 4 times 5 raised to the power 0. And this is going to give us 125 plus 3 times 25 plus 5x, because 5 raised to the power 1 is 5 times x, 5x plus 4. Since 5 raised to the power 0 is 1 times 4. So this is 125 plus 75 plus 5x plus 4. You quickly add up all these ones, the ones that are like terms. You have 125 plus 125 plus 75. This will give you 2 200 and plus 4. So you have 204. This will give you 204 plus 5x. You cannot add 5x to 204 because they are not like terms. So you do the same thing for this number. So y times 5 raised to power 3 plus 3 times 5 raised to power 2 plus x times 5 raised to power 1 plus 4 times 5 raised to power 0. So this is going to be 125y plus 5 squared is 25 times 3, 75, plus 5x plus 4. So this is going to be equal to, oh, it's a little mistake here. So this is not x, but 4. This is not x, but 4. So this place is it's corrected now. So this is, yes. So we have 4 here. 4 times 5, this is 20. Y, 5 times 5 raised to power 3, 3 times 5 raised to power 2, 4 times 5 raised to power 1, and 4 times 5 raised to power 0. And that will be it. So we add up the like terms, 125y plus, this is 75 plus 20 is 95. 95 plus 4 is 99. So this is the result of this. Now, quickly, we have what we have now is this. What we have now is 573 minus 204 plus 5x is equal to 125y plus 99. So if we open up everything, we are going to have 573 minus 204 minus 5x is equal to 125y plus 99. So if we collect the like terms, we are going to have 573 minus 204 minus 99 is equal to 125y plus 5x. So if we do all this subtraction, first we can add 99 plus 204, 99. This is going to give me 13 here. 13, you are going to have 10 here. Then you are going to have 3 here. That's 303. Now it now becomes 573 minus 303 equal to 125y plus 5x. So when we do this subtraction, 3 minus 3 is 0, 7 minus 0 is 7, and 5 minus 3 is 2. And this becomes 125y plus 5x. So what we have, you see that there's a number common to 270, 125, and 5. So we can divide through by 5. So that we are going to have divided by 5, divided by 5, divided by 5. So 5x divided by 5 is going to give you x, plus this divided by 5 is going to be 25y, and this divided by 5 is going to give you 554. 5 into 27 is 5 remainder 2, 5 into 20 is... So if you check this equation that we have now, you will find that the only possible number y can assume and x can assume to give you 54 is that y must be 2 and y must be 2, and x must be 4. So 25 times 2 is 50 plus 4. That will give you 54. So we can now therefore say x is equal to 4 and y is equal to 2. So our answer, we're asked to put the answer in this form, x, y form. So it's going to be equal to 4 and y is 2. Okay, now y is 2. So the answer is going to be equal to C. X is 4, y is 2. All right, next question is going to be this. Now it says y is equal to 23 base 5 plus 101 base 3. So like I said, what you do first is you assign the superscript, leaving your answer a base 2. You first convert all these ones to base 10, 23 base 5 to base 10, 101 base 3 to base 10, and later convert your answer to base 2. So this is 0, 1, 0, 1, 2. So there we go. This is 2 times 5 raised to the power 1 plus 3 times 5 raised to the power 0 plus 1 times 3 raised to the power 2 plus 0 times 3 raised to the power 1 plus 1 times 3 raised to the power 0. So this is going to be equal to 10 plus 3, because this is going to be 1. 5 raised to the power 0 is 1 times 3 plus 9 plus 0 plus 1. And this is going to give us 13 plus 10. 9 plus 1 is 10. 10 plus 3 is 13. 30 plus 10 is 23. So this is now in base 10. Now, to convert it to base 2, we do what is called continuous division. So this is going to be 23. 2 into 23 is going to be 1, 1 remainder 1. 2 into 11 is going to be 5 remainder 1. 2 into 5 is going to be 2 remainder 1. 2 into 2 is going to be 1 remainder 0. And 2 into, there is no 2 inside 1. So you just write down 0 and transfer this 1 here. Right? Now, you take the answer from bottom to top, and your answer is 1011 e base 2. 10111 e base 2. And B will be the correct answer. Next question. Next question is this. Now, what number base has been used here? So let the number be x. So this is 2263 base x plus 441 base x equal to 714 base x. So I'm going to expand this. So I'm going to have 0, 1, 2, 0, 1, 2, 0, 1, 2. Now, 2 times x raised to the power 2 plus 6 times x raised to the power 1 plus 3 times x raised to the power 0 plus 4 times x raised to the power 2 plus 4 times x raised to the power 1 plus 1 times x raised to the power 0 is equal to 7 times x raised to the power 2 plus 1 times x raised to the power 1 plus 4 times x raised to the power 0. So we clear up everything. This is 2x squared plus 6x plus 3 plus 4x squared plus 4x plus 1. Now, 7x squared plus x plus 4. Now, we are going to have x, 2x squared, 4x squared is going to give us 6x squared. Now, 6s and 4s is going to give us 10x. 3 plus 1 is going to give us 4, equal to 7x squared plus x plus 4. So if you collect the like terms, if you move 4 to this other side, 4 will cancel out. So what we have now is this. So 6, this is going to be 7x squared minus 6x squared, moving this 6 to this side. Then x to this side is going to be 10x minus x. So this is 9x equal to x squared. So if you like, you can write it as a quadratic equation, and x is a common factor here, equal to 9. So x is equal to 0, or x minus 9 is equal to 0. So x is also equal to what? 9. So x is 0, or x equal to 9. But we know that the base cannot be 0. So the base cannot be 0. So our final answer is 9. So this arithmetic was done in base 9. So next question. Next question is this. So we are going to, the simplest way is to add the positive number, then later subtract. So I'm going to do so. 2, 1, 2 plus 2, 2, 2, all in base 3. So 2 plus 2 is 4. 4 in base 3 is 11. So take 1 to the left. This is 1 plus 2. 3 plus 1, 4 is still 11. So take 1 to the left. So this is going to be 5. 5 in base 3 is going to be 1, remainder 2. That's why 5 in base 3 is 12. So you just write 12 in base 3. Then after which, we can now subtract 1, 2, 1. So 1 minus 1 in base 3 is 0. 1 minus 2. 1 cannot subtract 2. So you take a bundle of 3 from here and add it to this. So it's going to be 3 plus 1. That's 4. 4 minus 2 is going to give you 2. Now, after taking bundle of 2, bundle of 3 that represents 1 here, is remaining 1 here. So 1 minus 1 is 0. And 1 minus nothing is going to be 1. So this is 1, 2, 1, 0, 2, 0. And the answer is C. So that is it for this question. Next question is this. So we are meant to convert 72 bases to a number in base 3. So what we are going to do first is convert it to base 10 and convert it back to base 3. So this is 72 bases is going to be equal to that 0, 1, 7 times 6 raised to power 1 plus 2 times 6 raised to power 0. So this is 7 times 6. 7 times 6 is 42 plus 2. Because 6 raised to power 0 is 1. So this is going to give you 44 base 10. Now, what will we do next? We'll convert this 44 base 10 to base 3 by using repeated division. So we are going to have 3 to 4 is 1, 3 to 14 is 4, remainder 2, 3 to 14 is 4, remainder 2, 3 to 4 is 1, remainder 1, and 3 to 1, it cannot go, 3 cannot divide 1, so you write down the same 1, just transfer it from here to this place. I take the answer from bottom to top. and you are going to have 1, 1, 2, 2 in base 3. So the answer is going to be D. So this is where I am going to stop for today. We will meet next time. Thank you.